When tackling this project, our group decided to split our Minecraft village up into three main components, that being terraforming, pathfinding, and house plotting, with all of us working collaboratively to create our own individual houses that we can input on our plots. To begin the house plotting, I had to do some basic terraforming of our Minecraft village, which involved bulldozing an entire portion of land that gave us a clean slate in which we could build up from. This would allow us to experiment with pathfinding, house plotting, and house building, as well as terraforming the border of our plot to smooth and blend it naturally into the environment. The flat plane was great initially for developing upon. However, it was quickly noticed that our village was looking very bland and boring, as all the houses were built at the exact same height level. In order to beat this issue, I used something called the Perlin Noise Hill Generator and created a function that I could call that essentially allowed me to generate a natural looking hill on top of our bulldozed land. This was great, as it not only broke up the unnatural flatness of our village, but allowed me to build our houses at varying heights within the village. After having fixed the issue of our very flat and bulldozed land, the next big problem to tackle was to set up a plot system, whereby I could not only be able to test to see if a plot was in the bounds of our village, but also test to see if a plot of land was intersecting with an already existing plot. To achieve this, I created a recursive function that would generate randomized plot coordinates within the village boundaries, and if the plot was intersecting with other plots that had already been created, it would recursively call itself again and reassign the new plot coordinates until an available plot was found. After having worked out the plotting of each house, I was then able to create the foundation for which each house would lay on, giving us the X, Z, min and max boundaries. Moving on to the most crucial part of every village, which is the houses. For my portion of the houses, I wanted to make sure the houses were randomized as much as possible, as there is nothing worse than playing a video game and the houses you enter are repetitive and have the exact same layout each time you enter. To overcome this issue, I wanted to randomize three main components: the direction they faced, the room sizes within the house, and the number of levels that each house contained. All three of these components were randomly generated upon construction of each individual house, as well as randomizing the length, width, and heights of each house individually. This allowed me to generate each house as random as possible, with each varying of size, length, height, and also contents. On top of this, I had also begun doing some interior decorating of each house, placing some household items you would expect to see in random locations of the house. In addition, I also customized each house to vary the placement of objects based on the direction they were facing, that being north, east, south, and west. This was important as specific blocks such as chests and beds require a direction ID on top of a block ID. The final part of the house plots was to do some terraforming around each individual plot that would allow the pathfinding algorithm to climb comfortably to the entrance of each house. As A star, which was the pathfinding algorithm we used, can only climb at a max of 1 block in height, I had to make the house foundations increase by a value of 1 block in the X and Z direction while decreasing 1 block in the Y direction. This would achieve a gradual climb to each of the houses that the pathfinding algorithm would be able to use.
The path function was a struggle, and while we were able to create paths and avoid around most obstacles, if a large enough obstacle was confronted, it could cause the code to load for a very large amount of time. As a result, we have chosen to leave it out of the final village, as we did not want to cause the village to fail to load. However, this clip is included to show what work we have completed on the path, and this section of the video will demonstrate the pathfinding using A star and also the avoidance that was developed during the development of the code. We see this path going diagonal direction by increasing the X and Z axis one at a time. Here we see the path on a straight and simple line. It also demonstrates how the pathfinding method can take multiple destination points. The road would randomly be assigned different block types such as obsidian, gold, stone, and more. Here we see the path going up a hill. The path generates the line and increases the Y at the last moment. This could lead to the path sometimes being underground. However, using air blocks and loops, the area above the path was cleared out. It also means that the loop is used to place blocks below to ensure the path is not floating in the air and creates a bridge. This leads to a natural looking path that looks like it's been carved out naturally throughout the landscape. This clip here shows how the avoidance technique would have worked. The code grabs the two diagonal corners of this stone block area, which represent a house, and generates the points in between these. These points are added to a list called avoid, which is used to choose which neighbours cannot be selected. As seen here, the path generates around the block rather than going under, over, or through it. And finally, here are some of the places I used to develop the code, including Reddit, predefined code, and a YouTube video.